question asks us to convert a chair structure into a planar line angle structure as if we're viewing it from above. Let's go ahead and draw in our perspective eye, looking at this molecule from above. We can use kind of an Earth-planet analogy to help us decipher how we're going to turn this into its planar line angle structure form. The 6 atoms of the cyclohexane you can think of like an equator around the Earth. The perspective that we want to make sure we understand for the chair structure is that carbon 1, carbon 6, and carbon 5 are closer to you as the viewer, whereas carbon 2, 3, and 4 are further away from you as the viewer. When we're looking at this molecule, it's as if we're looking down from the North Pole and we can see the equator around the center, the circumference of the Earth. The first thing we should do is draw our cyclohexane in our line angle planar structure form, and we should number the carbon atoms as well. Let's put carbon number 4 at the top, and we need to continue to number this molecule. This one is numbered clockwise, and so we need to number this one clockwise as well. Now that we have the carbon numbers and we have our orientation set, we can add the substituents to this line angle structure. If we're looking down from the North Pole, what I want you to notice is that the isopropyl group here is sticking up into the northern hemisphere. If we take the 6 carbon atoms as the equator, the isopropyl group is in the northern hemisphere closer to the North Pole. Therefore, on carbon number 4, the isopropyl group is sticking closer to me as the viewer. If I'm looking down from the North Pole and the isopropyl group is sticking up into the northern hemisphere, it is now closer to me as the viewer. So on carbon number 4, on a wedge, I have this isopropyl group. On carbon number 1, I have a methyl group. This methyl group is also sticking up into the northern hemisphere. So if I'm looking down from the North Pole, this methyl group is also sticking up closer to me as the viewer. So on carbon number 1, also on a wedge, I will have the methyl group. One thing I want to point out is that at no point did I care whether the group was axial or equatorial. That's really irrelevant for this particular exercise. All I care about is if I'm looking from the North Pole, is that group up in the northern hemisphere closer to me on a wedge, or is it down in the southern hemisphere further away from me on a dash? This is how we can convert a chair structure into a planar line angle structure.